Welcome back to the cosmic voyage of a lifetime. Today, we're delving deep into the captivating world of galactic magnetic fields. That's right, galaxies have their very own magnetic secrets, and we're here to unveil them in all their cosmic glory. Get ready to be spellbound because this cosmic journey is going to take you on a ride like no other. In this episode, we will explore some of the most fascinating discoveries and mysteries about galactic magnetic fields. We will learn how they are measured and mapped, how they vary across different types of galaxies, how they interact with other cosmic phenomena. We will also discuss some of the open questions and challenges that remain in this exciting field of research. So buckle up and join us as we venture on this magnetic adventure across the cosmos. You won't want to miss this. Did you ever stop to think that each galaxy, including our cosmic home, the Milky Way, possesses its own natural magnetic field? It's a mind-blowing fact. But here's the kicker: these cosmic magnets are quite weak when compared to what we're used to here on Good Earth. In fact, the magnetic field of our galaxy is approximately 100 times weaker than the one we rely on to find our way with a trusty compass. But how do we know that galaxies have magnetic fields? And why are they so weak? Well, astronomers can measure the magnetic fields of galaxies by observing how they affect the light from distant sources, such as quasars. Quasars are extremely bright and energetic objects powered by supermassive black holes at the centers of galaxies. When the light from a quasar passes through a galaxy's magnetic field, it becomes polarized, meaning that its electric and magnetic components are aligned in a certain direction. By measuring the degree and angle of polarization, astronomers can infer the strength and orientation of the galaxy's magnetic field. The origin and evolution of galactic magnetic fields are still not fully understood, but there are some theories that try to explain them. One theory is that galaxies inherited their magnetic fields from the primordial plasma that filled the universe shortly after the Big Bang. Another theory is that galaxies generated their magnetic fields through a process called the dynamo effect, which involves the interaction of electric currents, rotation, and turbulence in the interstellar gas. A third theory is that galaxies amplified their magnetic fields through mergers and collisions with other galaxies. Now, let's get into the nitty-gritty. A galaxy's magnetic field has two fundamental components. First, there's the large-scale ordered pattern that mirrors the galaxy's shape. And then there's the small-scale random pattern. Here's the real twist: the random pattern is about 2 times stronger than the ordered one. So, if you were to measure the magnetic field at just one point in interstellar space, guess what? You'd mostly pick up the random aspect. This makes it virtually impossible to figure out your precise location or orientation in the galaxy. It's like trying to navigate in space with a compass that's lost its true north. But don't despair. Here's where the magic happens. Imagine if our hypothetical space probe took multiple measurements at various locations and then cleverly averaged them out. Suddenly, the large-scale pattern of the galactic magnetic field would emerge from the cosmic shadows. It's kind of like using the stars for navigation in a boundless cosmic sea, but instead of stars, you're using magnetic fields. So, what does this large-scale galactic magnetic field actually look like? Prepare to be mesmerized. The magnetic field lines gracefully run parallel to the galactic plane, crafting colossal azimuthal spirals that gracefully emanate from the galaxy's center. These spiraling magnetic field lines beautifully coincide with the galaxy's spiral arms, adding an artistic touch to the cosmic canvas. But here's the kicker: they point in different directions on different spiral arms. Some courageously point toward the galactic center, while others opt for the path away from it. It's a cosmic dance of polarities that's nothing short of extraordinary. Now, why is the magnetic field strongest near the galactic plane? Well, it's all about the matter. Most of the cosmic matter in the galaxy congregates around the galactic plane. The further you venture from this cosmic freeway, the weaker the magnetic field becomes. It's like losing reception on your radio as you drive farther from the broadcasting station, a weaker signal, but never truly lost. You might be itching to know how these magnificent galactic magnetic fields come into existence. It's a process known as the dynamo effect, and it's the same phenomenon that's responsible for our beloved Earth's magnetic field. Here's the cosmic recipe. The charged interstellar gas within the galaxy is in constant motion, all thanks to the galaxy's overarching rotation. Now, remember, when charged particles move, they create magnetic fields. It's a fundamental rule of the cosmos. But wait, there's more. The magnetic field generated by these charged particles doesn't just hang around idly. It influences their motion, amplifying the magnetic field while sapping away the particles' kinetic energy. It's like a cosmic tug of war, and the result is a complex, self-amplifying interplay between the moving gas particles and magnetic fields. This dynamic dance eventually molds a long-term, stable, large-scale pattern, the grand design of galactic magnetism. It's like Mother Nature's very own work of art, written in the language of magnetism. And there you have it, fellow space explorers. Galactic magnetic fields may be weak, but they are anything but ordinary. These invisible cosmic companions guide us through the cosmos, making our way through the universe just a tad bit easier. So, the next time you gaze up at the night sky, remember that even in the darkest reaches of space, there's a hidden force at play, the mesmerizing world of galactic magnetic fields. Thank you for joining us on this cosmic journey. And if you've enjoyed this deep dive into the cosmos, don't forget to hit that like button, subscribe to our channel, and ring that notification bell to stay updated on all things space-related. Until next time, fellow stargazers, keep looking up, and may the magnetic forces of the universe be forever in your favor.